All right, so we're going to do the interestingly titled GitOps Lifecycle Management talk for you all today. So let's start with the next slide. Yes, got it. Who I am. So I'm Jason. I'm a solutions architect with GitLab based in the Washington, D.C. area. And, a lot of my job is really talking to folks about how they're addressing challenges that they face and really trying to convince people to solve the underlying problems that will make life better for those that come after and those other folks that they work with. So here's a quick agenda of what we're going to be talking about today. So we're going to kind of go into my opinion of GitOps, right? And I'm promising you some controversial takes here in this chat today. And we're going to talk about what I think we need to remember to be thinking about when we're doing GitOps. I'm going to talk about Flux and GitLab CI/CD and some of the key concepts that allow them to work together really well. We're going to talk about managing the lifecycle of your applications and infrastructure. So from creation to operations through to retirement. And then we're going to wrap up. And if we have a bunch of extra time, I'm going to talk to you about the internals of reconciliation with GitLab and Flux. And please put questions in the chat. I will try and pay attention as we go. All right, so other folks have done it way better. Really appreciated the presentations today. Just to reemphasize, if you do GitOps well, you can go fast, you can be really reliable, you can provide a level of security and traceability that other folks don't have. And for those of you that have done any ITIL stuff, right, in my opinion, the thing I've loved most about GitOps is that it allows you to build a declarative configuration management database. And if you're not familiar with ITIL, go look up that particular term. I think it's really useful. But it shifts the relationship between desired state or actual state and configuration in a really positive way. It allows you to take your definition of state and make that authoritative on your environment. And that's a pretty awesome capability. But I actually see a lot of issues with GitOps, and we've had some of those questions today about, what about databases? What about VMs? What about things that don't necessarily fall under that cloud native umbrella, right? So GitOps is great when you're up and running and you got a Kubernetes cluster and it's going and everything's there. It's really well done, but I don't find it's as helpful when it comes to getting that environment ready to go or tearing it down when you're done. It's also really focused on Kubernetes, which is great for those of us that live in that cloud native space. But for many organizations that I talk to, you're lucky if that's 10% of your infrastructure. So we need to account for the rest. And this model that we talk about, this pull model that is really valuable and really powerful, it just doesn't work if the infrastructure managing doesn't have a built-in reconciliation engine, right? Which is what Kubernetes gives us. So I want to talk about something. This is my first, I think, real hot take of the call, maybe the second hot take of the call, which is I see two versions of GitOps, right? I see the pull-based GitOps that we've been talking about all day, where your config is being managed. This could have been worded better, right? Your config is being managed by the object under management, right? So Kubernetes is managing the config that is managing Kubernetes, which is great, right? A little esoteric, but great. And it's really good when it's up and running. And just Flux Bootstrap notwithstanding, I don't think there is a clear methodology for bootstrapping our infrastructure with GitOps. Push, however, is where config is managed by an external system, right? For those that remember the good or bad old days of Chef and Puppet, right? We had these systems that would manage all of our state, and they would go apply configuration to our virtual machines, our physical machines, whatever. But a push model actually works well with all the things that aren't Kubernetes in our environment, right? That's setting up our stuff with Terraform. That's using Ansible to configure our VMs. That's using, CloudFormation to do our Lambdas, whatever that may be. But it requires something external to GitOps to handle the automation. So what do I recommend, right? Like in my view, what I see work is a combination of push and pull models together, right? Go back to the previous speakers, and I'm not going to mispronounce any names, but there was a great story about a cluster that went down and how they rebuilt it. But in their story, right, the Terraform code to manage the cluster that they were looking at was part of the same repo that had the Kubernetes manifests. And I think that's a really common pattern. When we think about GitOps, we need to think about those things, those things together. So we need to treat our infrastructure as code and our GitOps in the same way. We need to combine them with a robust CI/CD system. Now, cards on the table, folks, I work for GitLab, right? So that's my job. But there's a lot of robust CI/CD systems out there. We heard a great example from somebody in the chat earlier about a tool that sounds really interesting. The core point is you need a CI/CD system that can watch your code repository, can handle all the various automation that you need, and that can serve as a central integration point between your various tools, right? And whatever you're using, you need to leverage lifecycle constructs within that CI/CD system, like releases, like OCI artifacts, like environments, some concept of a deployment target or an infrastructure environment, okay? And please put questions in the chat as we go. I will try and answer throughout. So this is why I really regret not having Kingdom go first, because I think he was going to explain all this stuff better than I will. But I'm going to talk about some Flux objects that are relevant to the example I'm going to show today. And more solidly, what I'm talking about today is I'm going to show you an example of how you can do cluster configuration and management. And then I'm going to show you how you can do application configuration and management with a combination of Flux and Terraform together, right? And ideally, you can generalize that to other environments. So when we talk about the Flux objects we're dealing with, a couple things are really important. So we've got this concept of sources, right? OCI repositories, which is a container image which can hold configuration data. We have Git repositories, which are another way to hold configuration data. And then we have Helm repositories, which just hold Helm charts, which could also be OCI objects, but that's a whole nother thing. We have releases. So we have a Helm release, which is like a Helm chart and its associated values. And we have customizations, right, which are Kubernetes manifests and optionally a customization file. One more, if we get into reconciliation later, we also have this concept in Flux of a receiver, which is essentially just a URL configured to receive a webhook and trigger something to occur within the cluster. Now we're going to go into some GitLab objects, right? Things that are relevant, and feel free to translate this to your own CI/CD system of choice, right? But we have a pipeline which defines what our automation will be. What are the steps? What are the gates? What are the deployment targets we're going to be using? We have jobs, which are essentially a unit of work within a pipeline. In general, it is a script, it is some variables, and it's a container that all get paired together to do something. In GitLab, we have environments, but I think many systems have some version of this, right? Which is essentially a unit of application or infrastructure management that allows you to see where your code is being deployed, can be subject to permissions like who or when are we allowed to change a given environment, can be a scope for variables, right? So allow us to say, hey, in prod, these are the values, in test, these are the values, in dev, these are the values. And then again, allows for management of a lifecycle. And just to redefine that one more time, that is the creation, the operations, the day two operations, and the retirement of a given unit of application or infrastructure. We have CI/CD variables, which are key and values essentially managed externally to your application code. So if you have, things in Vault that you want synced into Kubernetes, or you have values that you don't necessarily want to keep with your code but are important to configuring those environments, right? You can use that external value store to keep a simpler infrastructure as code setup and a simpler GitOps setup, and still have that differentiation that you need. Within GitLab, we have a construct that's important to this workflow that I'm going to show you, which is the Kubernetes agent, right? This is essentially a tool that manages connections to your cluster and allows you to do passwordless authentication, passwordless command sending to a given Kubernetes cluster. And then we also have a container registry, which is a place to store OCI objects that is subject to permissions and access controls. And just a quick diversion into OCI, right? So that's the Open Container Initiative specification. It's really neat, right? It has a cool history of how it came about, right? But essentially what this allows us to do is store just about any arbitrary artifact we want as a container image reference in an OCI store, and then pull that down and use it inside of our cluster. And that's a really powerful thing when you think of some of the things we can do with containers. Like, for example, we can reference containers with a SHA checksum, so we know exactly what we're getting. We can cosign container images, and we can validate the signature on those things so that we can be confident that we're pulling down what we think we're pulling down. Gives us a lot of additional security when it comes to managing what goes into our environment. So this is a busy diagram, all right? So apologies in advance. You know, what I'm going to tell you is this diagram and the next diagram both correspond to Git repositories that you're welcome to take a look at and use and test out and try in your own way. And so I'm going to try and explain the workflow here before you go start playing with it yourself. So I've got a project, right? I've got a cluster config project, and the intent here is that if I am a platform engineer at an organization, I need a standardized way to make infrastructure available to my application teams that they can consume, right? And this workflow allows me to build out the infrastructure and then configure it, right? Lay down those common features like a service mesh, like an ingress, like my monitoring tooling, whatever else is kind of standard in my cluster deployments. So inside my config project, I've got a pipeline definition, right? That tells GitLab how to go and execute all this stuff that we're seeing. We've got Terraform code, right? This could also be Ansible code. This could be CloudFormation. If you're doing it, it could be your bicep code. Should you want to try that? And then it also includes your Kubernetes manifest for what will be applied. It houses any CI/CD variables, and it can connect to a secret store like Vault or whatever your cloud secret storage management tool is. So the workflow that we're talking about here is one in which we can allow rapid iteration for our dev cluster and have a much more fixed and regimented process for deploying to our test environments or to our prod cluster, right? Like we talk about outages that can occur as we make changes to our manifest, right? We actually want to take, if you consider, we want devs to go to dev, then test, then prod, right? And check things along the way. We need to be taking the same discipline to our infrastructure. And this workflow allows us to do it. So in our example, we'll deploy to dev as we make a change. We go through a pipeline specific to managing the cluster, where the cluster is created if it needs to be created. Configuration is applied by Flux. And importantly, that configuration is pulled directly from the Git repository and the branch we're working on. Directly from the Git repository and the branch we're working on. So as we change things, pardon me, as we change things within our project, our repository, those changes are immediately reconciled and reflected within the cluster because we've got this direct Git repository flow. We apply our configuration, we validate the cluster, and then we move on. And if, as we're doing this, we find that we make errors, we can go back through a rapid dev loop here, where the changes we make in our config project are represented and shown in the dev cluster. And then when we're ready, we can say, listen, we're past our initial dev gate, let's sign off, and let's create an artifact that will be consumed by our test cluster, by our prod cluster, in order to make these changes official across our environment. So in the example that you're going to see, when we're done with deploying to dev, we package our config as a cosigned OCI artifact that we send directly to our GitLab registry. Then we go on and we deploy to test. And as we do so, we reference that container image by its checksum value. And then again, create the cluster if required, or make any changes that the Terraform tells us to make regarding that cluster configuration. We apply the updated configuration, the Kubernetes manifests that make our platform on that cluster, but we do it via an OCI repository pull, where we know exactly what we're pulling, and we're able to cryptographically validate that it comes from the place that we say it comes from. So we have a lot of certainty about what's going on here. And then we can represent that exact same config, and we pull that exact same config object for UAT and production. And we have place for a prod gate in between. We can use the environments to say, should you be allowed to deploy during this window? Who is allowed to approve this? Integrate with our various change management systems. All making sense so far? All right. Now we're going to talk about an application workflow that we can follow for the same basic effect, right? So if you look at here, we color-coded things on purpose, right? So in this example, we show you how to create a dev cluster, a test cluster, and a prod cluster, and then make those available to your application teams. So we've got the same colors here. So reviews deploying to the test cluster that the infrastructure team created. The UAT cluster is the test cluster from before, and so is the prod cluster. All right, so again, what we're doing here when we think of an application flow, we're making sure that we have an app repo with our application code, Kubernetes config, and our pipeline. Yep, talk coming up, got it. And our pipeline. And what we do here is typically our developers are going to go and create a new branch for whatever feature they're working on. And that Git repo at that branch is going to be pushed to the review environment and tracked by Flux. So GitLab CI/CD will create the Git source object inside the review cluster. It will update it with the branch that we're working on. And then from there on out, Flux will handle reconciliation. I really have to mute my things there. Yep, thanks. Oops. Flux will handle that regular reconciliation, right? Then we can begin our tests, right? So whatever testing we need to do, we have validation approval. And if we need to rework, we've got a very fast inner dev loop for our developers to make changes, deploy it directly to review, and see the effects of this on their code and on their deployed application. When it's ready, they can merge, once again, publish and sign, and deploy those exact same artifacts to UAT and production, following the rules that we have for UAT and production, because those environments in our CI/CD system are kind of first-class objects. So I don't think this will be complete without a pod info demo. So I'm going to give you a show of using pod info and environments together in GitLab. So here we've got our environments, right? So I've deployed an application. This is the pod info application. I've got it. It was deployed to a review environment, but that review environment deletes itself automatically after an hour. So that's gone. But we have a UAT environment. Oh, you can only see the slide. Great. How do I fix that? Give me just one sec. That's why I wasn't sharing the entire screen. Oh, so that means you guys have missed my laser pointer the whole time. Ah, darn it. Okay, thank you so much for the heads up. What I've got here is two deployments. So I've got pod info, and it's deployed into production, and we can see that production has a classic pod info with the cuttlefish waiting for something new to come along. But we've created a change already. We've created a change already, and we can see what that looks like in our UAT environment. We can decide, are we ready to push this through to prod? Okay, so we've replaced the cuttlefish with our GitLab Tanuki. That's great. And now we're going to actually promote this through and let that change go. And so we can see the same pipeline that I tried to represent in that diagram over here in what it looks like in a GitLab environment, right? So we have our deploy to review, we've packaged our config, we've deployed the UAT, and now we're ready to go to prod. So I'm an approved prod deployer, so I can press play, and this will go through and apply to prod. And if I want, I can also stop our UAT environment because we don't need that anymore. We're done. We're ready to go through to production. And we go back to our environments, and we can see this thing shift from being our cuttlefish to being our Tanuki as the Flux job goes in, or as the pipeline goes in and reconciles what is currently in the prod cluster, which is the old OCI artifact, to the new one where we now have the GitLab icon. All right, now let's go back to some slides. So that's the key. That's the key piece, right? So what I wanted to convey today is that GitOps is incredible technology, right? And incredible tooling. And it's an important part of a CD pipeline, that full continuous delivery story. And I think it's divided into two main models, right? A push-based and a pull-based pattern. I think there are foundational concerns that everyone needs to think about when they are building out their GitOps pipeline, their GitOps tooling. Right, we need to consider how are we going to manage the lifecycle of the applications we deploy, scaling up, scaling down, and creating new apps and turning off existing applications. We can't, GitOps doesn't end at the deployment, right? We need to consider how do we integrate with testing, with governance, right? I think the very first talk today really talked about this. That there is a lot more to what goes on than just deploying into that cluster at the end. And we need to think about how do we secure our pipeline while satisfying the needs of governance, compliance, and change management. All right, so I've got some resources for you to take home. Expect some of these things to change, specifically the two projects that I own there. But we've got a cluster config project, which shows you that infrastructure pipeline so you can see what that looks like and reuse it in your own environments. You've got the pod info example where we're doing the same thing with that pod info application. Now inside GitLab, we have this concept of CI/CD components. So these are reusable tools that you can take and do things with. There is a Flux CI/CD component that is really worth checking out. And the tooling that we have for deploying the clusters and deploying the applications are all being moved into that Flux CD component. So watch that space. And here's a great blog on using OCI images with Flux. And I think we're about at time, so let's do questions, and I won't show you how the reconciliation stuff works. All right, so it looks like there's a lot in Q&A. I've never heard so Florian, I've never heard the term review environment. Yeah, it's like dev, there's a bunch of different ways you can say it, right? But it's just that ephemeral environment that you would use as you're developing an application to make sure that it meets your needs. Or if you're working, like imagine you're working with a UX person or a designer, right? It's a way to give them a copy of the application that they can look at and use. Yeah, how does GitLab CI know? So great question from Guillaume. I'll just share real quick. So there's a couple slides in here. So if you look at the whole deck after the fact, if you look at the whole deck, there is some slides that talk about reconciliation and how they work in a lot more detail. So take a quick look at that, and it'll explain a lot of it. If you do want to keep in touch, you can find me on LinkedIn. I'm on the CNCF Slack at JMO. And if for whatever reason you want to look me up on gitlab.com, you can do it just at rjmo. Oh, right. So this is a great question from CA. Sorry, I'm probably not going to try and say that last name. What about managing multi-arch? Very often GitOps platforms will provide build, run, and test environments for x86, but you'll have to have a jury rig your own for S390X, whatever, ARM power. Yeah, so it comes back to like, how do you decide what is GitOps? And I know that Scott will talk about the Open GitOps project, which is a great thing to look at, and they have good definitions. So it depends what you mean by it, but you can use automation engines with the appropriate runner type, that is the appropriate executor for the architecture you're working at, so that you can build your artifacts and deploy them using the same architecture of the system that you're going after, right? Although, if you're going after mainframes, that can be a little bit more challenging. Not that it's not possible, but it's not simple. Any other questions? Oh, Benoit. Do you mind if I answer Benoit's question before we go?
Yeah, if you can do it in a minute.
Yeah. So how can you tell when it's deployed to the correct user, or to the correct user who performed the merge or deploy action? It seems Flux doesn't have the information. It doesn't, right? That's a great question, which kind of goes back to my key point of why we need to integrate with a full CI/CD system, right? You can't ignore those concerns, but at the same time, Flux or Argo can't really hold all that. Although you'll have folks that know Argo way better than me who maybe will tell you better. Maybe I'll tell you better. And I think that's it, folks. Thank you so much for listening.
Yeah, Jason, thanks so much.